everybody. Yesterday we discussed a little bit about the definitions on the chapter test of hypothesis. What is null hypothesis? What is alternative hypothesis? Then simple and composite hypothesis, type 1 error, type 2 error, etc. And finally we finished our discussion with the idea of the best critical region and most powerful test. Today, what I shall discuss would be the application of those results or those definitions. And in this class, I think I would not discuss the detailed proof of all these results. Rather, today I shall discuss some technical, or what should I say, some methods for computing for performing this test of hypothesis of for different null hypotheses against different kind of alternative hypothesis. So in the last class we discussed that the null hypothesis is generally written by in this type of notation H0 H0, and alternative hypothesis is written as H1. In the test of hypothesis, this null hypothesis is always tested against alternative hypothesis, and depending upon this alternative hypothesis, we actually construct the critical region. What kind of alternative hypothesis we shall discuss during this lecture, and altogether we shall mainly divide this lecture into two categories. One would be the test for a single population distribution, another would be the test for simultaneously comparison of two population distributions. Mainly we shall concentrate on normal m sigma distribution, and depending on normal m sigma distribution, we shall need to make the hypothesis on the parameter m and on the parameter sigma, etc. Different type of hypothesis should be tested against different type of alternative hypothesis. So I have tried to make it systematic, and I am presenting this one by this type of table. Over here, in the normal m sigma distribution, first of all, we are going to test some hypothesis involving the population mean small m. So let us consider this type of null hypothesis m is equal to m0. Okay, against the alternative hypothesis, there may be different type of alternative hypothesis. First of all, we consider this type of hypothesis that m not equal to m0. And in that case, what we do in this type of test is actually we identify a test statistic which is dependent on this parameter value involving this null hypothesis. Okay, so over here and we shall try to construct a statistic whose probability distribution would be known to us. We have already discussed three type of statistics in the previous chapter, and this is one such statistic. U is equal to root over of n into x bar minus m0 divided by sigma, and we know that in case of normal distribution, this statistic U follows a normal m sigma distribution. Generally, whenever a statistic follows a certain distribution, we generally write it by the help of this type of tilde notation. We say that this statistic U follows normal m sigma distribution, normal 0-1 distribution, the standard normal distribution. Normal 0-1 distribution is represented in this fashion within bracket 0, 1. That means m is equal to 0 and standard deviation sigma is equal to 1. In case of normal standard normal distribution, m is equal to 0 and sigma is equal to 1. Okay, So you follow the standard normal distribution. This means that you follows this type of normal distribution with parameter 0, 1. This is a known distribution. And we all know the density curve of normal distribution, this type of density curve. This density curve is symmetric about the middlemost mean value, extended from minus infinity to infinity. Now, depending upon this type of alternative hypothesis, we shall have to identify this critical region W. We shall have to identify the critical region W. And how to identify this one? Let me show you over here. You see the null hypothesis. Let me write it in this color. The null hypothesis H0. This is the hypothesis M equal to, suppose, certain given value m0, maybe 30, maybe 40, maybe 50, depending upon the question, against the alternative hypothesis H1, such that m not equal to m0. Now, if this type of hypothesis are there, in that case the critical region is to be constructed in this fashion. Suppose this is the density curve. This is the density curve that would be symmetric about the point, about the middlemost point. Suppose this is the density curve of the standard normal distribution, and in case of standard normal distribution, 0 is the mean, so this value would be is equal to 0. Now, if this is the alternative hypothesis H1, in that case the critical region will be will lie on both sides. It should be symmetric, although the picture is not very much symmetric. My drawing is not very good. Anyway, so it would be in this fashion, and this we shall have to identify this much area, and this much area will represent the level of significance or the maximum tolerable value of type 1 error. We generally represent this total area by epsilon. Significance level, we call it significance level. Significance level. Now, generally this value of epsilon is generally taken as equal to 0.05 5% significance level, or we sometimes call it 0.01, that means 1% significance level. So we try to restrict the maximum probability of type 1 error as 5% or 1%, something like this. This is the probability of type 1 error. Now, if this epsilon is divided into two portions, then this area would be is equal to epsilon by 2. This area would be is equal to epsilon by 2. And suppose this value, this point, and this point, we suppose that these 2 points, and over here suppose these 2 points is equal to u epsilon and minus u epsilon, symmetric about the origin. Then how to determine u epsilon? You see, this much area would be is equal to epsilon by 2. This area is actually representing the probability of what kind of event? Probability of the event that u greater than u epsilon. This is the zone actually, u to u epsilon to over here up to infinity. This type of open interval, semi-open interval, or you can consider the total interval extended up to infinity. That is actually the event obtained by u greater than u epsilon. This type of event, this type of inequality. So its probability, the probability of this inequality would be is equal to epsilon by 2. Okay, and if suppose this epsilon value of epsilon is taken to be is equal to 0.05, in that case what would be the value of epsilon by 2? This value of epsilon by 2 would be is equal to 0.025. So in this fashion you shall have to identify the this right hand side probability, and once you identify this right hand side probability, you would be able to identify the value of u epsilon from the normal distribution table. Okay, But if the alternative hypothesis is written in this fashion, H1, let me write it over here. If the alternative hypothesis is written in this fashion, H1, where m is greater than m0, it depends upon the question how to choose the alternative hypothesis. I shall discuss one or two examples on this type of problems. And m is greater than m1 is suppose the alternative hypothesis. In that case, the critical region will get changed, and you see over here this type of tests are called two-tailed test. This type of tests are called two-tailed test. Over here on both sides the critical region is extended. This is called two-tailed two-tailed test. And how to write this critical region? You see, this is the critical region extended from u epsilon to infinity, and on this left hand side the critical region would be extended from minus infinity to minus u epsilon, minus u epsilon. Okay, and u epsilon is to be determined by this type of inequality, by this type of limit. So what would be the critical region W? Over here W, the critical region would be actually the union of both of these two. So we can say that from minus infinity to u epsilon union union u epsilon to infinity. This would be the critical region. As you can check over here, you see this is the critical region, minus infinity to minus u epsilon and then u epsilon to infinity, and this is the inequality which by which we will find the value of u epsilon over here. Now once you consider this type of hypothesis, m greater than is this type of alternative hypothesis, m greater than m0, then what happens? In that case, the critical region, the position of critical region will get changed. Suppose this is the density curve. If this is the density curve, suppose, and so this is the axis, and over here say this is the middlemost point, and in that case it can be proved that the critical region will be only this right tail. That means entire probability epsilon, this much probability, the level, this significance level, this maximum probability of type 1 error, this epsilon would be situated on the right tail only, not in the left tail. Okay, and therefore this u epsilon, should be determined from this type of probability, that u greater than u epsilon. U greater than u epsilon, this value, in the first case this much u epsilon was situated on the right side, but over here on the total epsilon, this much epsilon by 2 was situated on this much epsilon by 2 area or probability was situated on the right hand side. But over here in this case, this total area or the total probability epsilon is situated on the right hand side, therefore this probability would be is equal to epsilon. In the previous case the probability was equal to epsilon by 2, but in this case this would be our epsilon, only this epsilon. Got it? And this type of tests are called right tailed test. Right tailed test. Right tailed. We will write it over here. Right tailed. Okay, this type of probability is called right tailed test, and in this case the critical region W, the critical region W is equal to the region starting from u epsilon to infinity. So this is the case when h is greater and the alternative hypothesis h1 is given by m greater than m0. All right. Now come to the third case, when the alternative hypothesis h1 is like this, m less than m0. In that case, what would be the density curve? This would be the density curve. Suppose this would be the density curve, and over here in that case the critical region will be situated on the left, this type of region. And this would be the middlemost point 0. So this much area would be is equal to the area epsilon. And so if we in general, what is the convention is u epsilon is chosen as positive. So that on the left hand side we mark this expression as equal to u minus u epsilon. So if you consider this type of point is equal to minus u epsilon, maybe -3, -4 or something, then correspondingly one such u epsilon would be there. Okay, and this due to symmetry, this much area this u epsilon should be written by this type of inequality, probability u less than u epsilon minus u epsilon less than minus u epsilon. This probability would be is equal to epsilon, and due to symmetry it can be shown that this is exactly identical to the fact that probability u greater than u epsilon probability u greater than u epsilon is equal to epsilon. Okay, what we are doing is that we are actually identifying a numerical value value of this minus u epsilon. If suppose this is -5, we are trying to identify what is the value of this u epsilon, whether it is 5 or 4 or something like that. And if this area is equal to epsilon, in that case this much area would also be is equal to epsilon. Okay, so we are actually trying to identify the value of this minus u epsilon, but we are taking the help of this much area. This much area would also be is equal to epsilon, and in this case what would be the critical region W? In this case over here, the critical region W would be actually this type of starting from -infinity to minus u epsilon. Okay, -infinity to minus u epsilon. This would be the critical region, and we are actually trying to find out the value of u epsilon by the help of this type of inequality. So I think and this type of test over here, this type of tests are actually related with the critical region situated on the left. That's why this type of tests are called left-tailed test. Left-tailed or left-sided. Left-tailed test. Okay. So this was both-sided test or two-tailed test. These are right-tailed test and this is left-tailed test, or we call these two together as one-tailed test. This is two-tailed test and these two cases are actually one-tailed test. Okay, so now let's go to an example. I think the idea would be much more clear if we consider an example on this type of problems. And the remaining other problems would also be exactly similar. So rather, let's consider a problem from your book. This is an example. What does it say? It says that this example. It says that in a ceramic industry, the population of percentage of yield of first class material was known to have a mean 72.5. In certain ceramic industry, they are producing different ceramic items, and the population of percentage of first class material, how many such first class materials are produced throughout the entire production process. Maybe it is a process of 50 years long, or maybe the industry is about 200 years long. Okay, whatever it is, altogether the total population, out of this total population, they are producing first class items having mean 72.6%. Okay, and the standard deviation is equal to 2.4%. So this is the result obtained from the previous some information, maybe some past large sample, etc. Now, what they are doing, what are the company, the owner of the company is doing? It is giving some incentive bonus to the workers. A new incentive bonus was declared, and a subsequent sample of size 15 from the population gave a mean of 74.3. Okay. So after giving some incentive bonus to the workers, it is expected that yes, workers will perform better after getting such bonus, and therefore the company is trying to verify whether indeed there is any such improvement of the quality in the production process. All right. So they have taken a sample of size 15 and wants to know whether from that sample we can conclude, we can make any conclusion regarding the quality of the next or upcoming production batch. All right. And suppose in this sample size of in this sample of size 15, the sample mean comes out as 74.3. It looks that yes, sample mean is greater than this previous population mean, 72.6. Sample mean is greater than this previous population mean. But whether the after declaring this type of incentive, whether the subsequent part of the population, whether the next and subsequent part of the population has got any better quality of production process or not. Let's see whether the population mean has increased or not. What is the question now? It is very important part in construction of this alternative hypothesis H1. Okay, this much information is provided. Okay, fine. Now, next is the question: does this reasonably show that the bonus really helped raising the average yield percentage? This is an important part. This is raising. It is not asking about the downfall of the average yield percentage. It is the question is that whether the average mean AM is greater than the previous mean value 72.6. Whether this is greater than the previous mean value 72.6. Okay, so this is the basic question, and that you need to identify in terms of this type of mathematical inequality. And always the null hypothesis is written in this fashion: H0 says that m is equal to m0. Then we are actually testing this type of hypothesis. Then which one should we consider as this hypothesis? We are left with one hypothesis, that H1, the alternative hypothesis, m greater than 72.6, and this 72.6, this value would be actually the value of this m0. Okay, so what we are trying to do, we are actually trying to verify this type of null hypothesis, whether m is equal to 72.6 or not, against the alternative hypothesis m greater than 72.6. As because the alternative hypothesis is represented by greater than inequality, therefore this test would be a right-tailed test. And in the right-tailed test, what I told you over here, you see this is the right-tailed test. This probability u greater than u epsilon should be obtained by this type of epsilon. Now the question is that what is epsilon? Nothing has been mentioned over here in the question regarding the significance level. If try to remember in this fashion, that if the in the question no information is provided, you can without any problem you can either choose epsilon is equal to 0.05, that means 5% probability, or you can choose epsilon is equal to 0.01. We mostly perform the test with this epsilon is equal to 0.05 with 5% level of significance. Okay. Now you see, I am going to show you the solution process, but is this much clear to you? The question, what is the, how do you construct this null hypothesis, how do you construct this alternative hypothesis? Hello?
Yes, sir.
কারোর কি কোনো জায়গায় কোনো প্রবলেম আছে? এই জায়গাটা, এই কনস্ট্রাকশন প্রসেসটা কিন্তু খুব ইম্পর্টেন্ট। কোশ্চেন এই জায়গা থেকে আসবে, এই চ্যাপ্টার থেকে যদি কিছু আসে, এইসব কোশ্চেনই আসবে। কোনো কোশ্চেন নেই? ক্লিয়ার সো ফার?
হ্যাঁ স্যার।
Okay. So now let's move to the solution portion, and in the book at least, in the book at least, they have adopted a little different type of significance level probably. Let's check. No, they have taken this epsilon is equal to 0.05 with 5% level of significance. Now you see, I forgot to tell you one thing, that this type of in this type of question, the information for standard deviation should be standard deviation of the population, okay, not standard deviation of the sample. The information for the standard deviation of the population should be provided, and that has been provided over here. It has been shown that this sigma is equal to 2.4. So over here this sigma should be is equal to 2.4. But if the standard deviation, if this information about the standard deviation is not provided, if this information of standard deviation of the population, not, I am not talking about the standard deviation of sample, okay, I am talking about the standard deviation of the population. If the standard deviation of the population is not provided, in that case we have to consider a different type of statistic, and that I shall discuss later. Anyway, so this is the case when sigma is equal to 2.4. Over here the test statistic was u is equal to this type of test statistic, a root over of n into x bar minus m0 divided by this standard deviation sigma. So already sigma has been provided in the question, and what is the sample size? Sample size n is equal to 15 over here. And x bar, what is this x bar? The sample mean of this population is equal to this x bar, that is 74.3. all right, and therefore we can say that over here we have x bar is equal to this 74.3. and with this much information, what is m0? I have already told you that this m0 is equal to this 72.6. Now considering all these values, we shall have to consider, we shall have to construct, in fact we shall have to compute this value of the test statistic. U is equal to root over of n into this much information x bar minus x0 divided by sigma. So we shall have to consider, we shall have to compute this value, and probably they have computed the value. Let me check where. Yes, they have computed the value over here. U is equal to root over of n into n into x bar minus m0 divided by sigma, and it comes out that the value is equal to 2.74. okay, so this is the value of the test statistic, 2.74. Now what is the we already got the value of the test statistic. Now what would be the critical region W? You see, I told you that W would be is equal to the critical region. This is a right tailed test, so the critical region would be U epsilon to infinity. Now what is U epsilon? U epsilon should be computed from this type of inequality, that U greater than U epsilon, this value should be is equal to 0. This value should be is equal to epsilon basically, and this epsilon has been taken as 0.05. And now from the normal distribution table, I already demonstrated the normal distribution table earlier in the previous classes. Let me demonstrate it once again. From the normal distribution table, at the end of this book, you have this normal distribution table. It's near about 300 pages or something like that. Let's check. No, at the end, probably about Distribution table. Yeah, standard normal distribution table. There you will have to identify this. These are all probabilities. These are all probabilities. Now in this probability you shall have to identify where is 0.05. Let's check 0.05, or some nearby number. 0.04 over here, 0495, and 0505. Actually, whenever you will round it off up to two decimal places, this value would be is equal to 0.06. So forget about this value. Rather consider this value, because when you round it off up to two decimal places, this value would be is equal to 0.05. Now try to identify corresponding row, this value, row heading, and this column heading, these two values. What was the row heading? The row heading was equal to 1.6, and the column heading is equal to 0.05. This is the column heading. So if we just add these two row heading, 1.6 plus 0.05, that would be actually the value of u epsilon, 1.65. 1.65. That would be the value of u epsilon. All right. So in this fashion, you would be able to identify the standard this value of u epsilon from the standard normal distribution table. Now let's get back to the previous question where I left. Where was the question? Let me search it. Yes, over here. Yes, this one. So what we got? We got the result that over here, this u epsilon, the value of u epsilon is equal to 1.65 obtained from the table. However, as far as I can remember, the value of u epsilon up to 3 decimal places. This was a result up to 2 decimal places. As far as I can remember, the value of u epsilon up to 3 decimal places would be is equal to maybe I think 1.645, something like this. Anyway, whatever it is. So now you see the critical region. This critical region would be this type of region starting from 1.64 to infinity. Now you see this value of the test statistic, this value of u, this value of test statistic actually belongs to this critical region. And if the value of the test statistic falls inside the critical region, then we shall have to reject the null hypothesis and accept the alternative hypothesis. That would be the basic final conclusion. So we shall have to reject the null hypothesis and accept the alternative hypothesis. You see over here it has been written, since this value of u falls in within the critical region w, I am denoting this critical region as w, we reject the null hypothesis, and of course in that case we accept the null hypothesis. And what is the we accept the alternative hypothesis. And what is the alternative hypothesis? The alternative hypothesis was m is greater than m0, something like this. So the alternative hypothesis should be true. That means yes, the mean value of the population has increased after giving proper incentive. All right. So we can technically say that there is a significant reason. Now I am using a technical term. Okay, I am using a technical term, significant. Actually, whenever we consider epsilon is equal to 0.05, and then the decision made by this type of for this type of epsilon is called significant decision. Significant in what sense? Significant. Hmm. Significant in what sense? In the sense that we have certain significant reason to make our conclusion. Over here we are accepting this h1. What was h1? H1 was that this type of m greater than m0. So we say that we have significant reason to accept the h1. That means we have significant reason to believe that the population mean m has increased after giving proper incentive. Hmm? And if this epsilon is taken as 0.01, all right, then in place of significant we call it highly significant conclusion. Highly significant conclusion. That means we say that if suppose if we consider epsilon is equal to 0.05, and in that case if we accept the alternative hypothesis, in that case we would say that we have we have highly significant reason to conclude that m is greater than m0. So in this way we make our conclusions. These are actually technical or mathematical terms. Okay, just in order to designate the level of significance. Okay, and remember, whenever you make any conclusion, don't forget to make or don't forget to mention the level of significance. So in this case, in our case, we have taken this epsilon is equal to 0.05. So we can say that we have significant reason to believe that the population mean m is greater than the previous population mean, with significance level epsilon is equal to 0.05. So you shall have to make this type of conclusion. Although in the book it is not properly written that yes, it is reasonable to believe that the incentive bonus was really effective is confirmed, but you should write it in proper technical term. Okay, so this is the first problem that I wanted to discuss over here. Now I am going to discuss few other cases just by changing this same example. I shall make some changes in this example, and I shall try to demonstrate the other cases. What are the other cases over here? The other cases, by other cases I mean to consider the case where sigma is unknown quantity. Over here you see the value of this sigma was provided. Now we are considering the case when this sigma is unknown quantity, and if sigma is unknown, in that case we shall need to consider this type of statistic: t is equal root over of n into x bar minus m0 divided by s. It can be proved that it follows a t distribution with nu is equal to n minus 1 degrees of freedom. This degrees of freedom is actually a parameter. So now let's firstly try to read the t distribution table. Okay, how to identify this t distribution table? Let me again go back to this t distribution table. Let me, this is standard distribution, then we have I-square distribution, then probably this is t distribution. Yes, this is t distribution. So let me rotate it. How to rotate it? View is rotated. You see over here, in this t distribution table, what are these quantities? These are actually the level of significance. Over here, if we want to find out this type of expression, this type of if we have this type of expression, that let me show it by drawing the picture. You would get this picture at the beginning of this all this table. Hmm. The density curve of the t distribution is exactly more or less approximately similar to the standard normal distribution, and it can be shown that if we keep increasing the this degrees of freedom, in that case it converges to the normal distribution. So this is very close to the normal distribution. The mean is equal to 0 over it. The standard normal distribution. This is the 0 value. And again, you will have to have this type of epsilon. So if suppose this value is equal to epsilon, in that case, how to identify this u epsilon? This is suppose this number. This number, not u epsilon, rather we call it t epsilon, as because it is coming from t distribution. So we call it t distribution, t epsilon, and we can say that probability t greater than t epsilon, t epsilon, this probability would be is equal to epsilon. Now, what would be its probability? Suppose epsilon is equal to 0.05. Suppose this epsilon is equal to 0. Or 0.5 or 0.25, something like this. 0.25 suppose. Now if this is 0.025, in that case you shall have to identify this column first. 0.025, 0.025, 0 should be there. Okay, so you shall have to identify this column. Now once the sample size is provided, once n is equal to provided, suppose in the previous example the sample size n is equal to 15. So over here the degrees of freedom nu would be is equal to n minus 1. So nu would be is equal to 14. All right, and this left hand side, these values, this left hand side, this represent the degrees of freedom. Although it is written as n, so don't consider this n as the degrees of don't mix this n with this nu. In this table they have used the notation n, but in our test of hypothesis we use this type of notation nu. So we shall have to identify the degrees of freedom over here. So it is 14, it should follow 14 degrees of freedom. This left hand side represents the degrees of freedom. Okay, so now let's try to identify where is 14 degrees of freedom. This is our 14 degrees of freedom, this one. You can see this is the 14 degrees of freedom, and you shall have to move along this row, come to this value. You see this is the column for 0.025, and you can move along this direction, and you consider the intersection, this value, this is 2.145. This value would be now the value of t epsilon, 2.145. So in this case, what would be the value of t epsilon over here? T epsilon is equal to 2.145. So in this way we identify the values of t epsilon from this table. Okay, now once you get the value of t epsilon, you can depending upon the alternative hypothesis. In the previous case, you see what was the alternative hypothesis? This was the alternative hypothesis, m greater than m0. All right, and there due to this type of alternative hypothesis, epsilon, the value of epsilon on the right hand side was taken as equal to 0.025. Now once this value is instead of 0.025 we have 0.05. So if this right hand side is equal to 0.05, then we shall have to consider this column. Now it depends what kind of test we are performing. If this is both sided test, then this epsilon probability will be actually distributed on both sides. So on the right hand side we will have epsilon by 2, this type of probability. So now over here you see, if this value is equal to 0.05, all right, if this value is equal to 0.05 and we are given that nu is equal to 14. So in that case you shall have to consider this value 0.05 and this value 14. So you shall have to move along this direction. Okay, and from this one you shall have to move along downward direction. From this direction you shall have to move in downward direction. Now check what is the intersection. This value, this is the intersecting value, 1.176 1.761. 1.761. Therefore in this case this value T epsilon is equal to 1.761. So now the critical region was W. The critical region would be, in case of right tail test, the critical region would be T epsilon to infinity. And this would be the critical region. So the value would be 1.761 starting from this point to infinity. So just exactly in the similar fashion as in the case of standard normal distribution, when sigma was taken to be as a known quantity. Now in this case sigma is an unknown quantity. So what is this t distribution over here? You see, let me write it over here. What is this t statistic? This statistic is now root over of n into this x bar minus m0 divided by small s. Now what is this small s? Small s is computed from this type of value. Small s was equal to n s square divided by n minus 1 root over of this expression. This is, so these are our smalls. So a square is to be provided. That means a square is the sample variance. The s is the sample standard deviation. Sigma is an unknown quantity. That's why in place of sigma for standard normal distribution, we have considered this s, and it can be proved that it actually follows a t distribution with n minus 1 degrees of freedom. And this n minus 1 is actually related with this value. Okay, so this is the case, and over here n is equal to 15. You see what was x bar in the previous problem. Let me go back to the this value. Let me just consider this value. T epsilon is equal to 1.1761. So over here this T epsilon is equal to 1.1761. Now what was the alternative hypothesis? H1 m greater than m0. So I would advise you to draw this type of graph, because this type of density curve, because this type of density curve will help you to identify the this value. Over here this is a right tail test because of the fact that this alternative hypothesis m is greater than m0. So probability t greater than t epsilon, that would be is equal to epsilon, and over here epsilon is equal to 0.05. Okay, with nu is equal to 14, that is n minus 1 degrees of freedom, that is equal to 14 degrees of freedom. So we got this result T epsilon. Therefore the critical region W is equal to this kind of 1.17612 to infinity. Now you will have to identify this value of small s, and in order to compute this value of small s, you have to identify what is the value of s square. Now let's consider a problem. Let's go back to the previous page number. Over here you can consider this type of problem, the same problem. The same problem with just one difference is that one difference, they did not say anything about it, that oh yes, with the one difference that without we can solve the problem, we can also do without assuming regarding the standard deviation. What was the standard deviation that we considered? This much information was provided: sigma is equal to 2.4. But if it is not provided, then what happens? Then already what we have given that the population mean is equal to the sample, the population mean is equal to 72.6, and sample size was is equal to 15. Now, if the if in this example, if along with that, if this value of s square, that is population variance, if this value of s square is provided, in that case we can compute the value of small s. I don't know whether in the next example such information is provided or not, but that should be provided. Then only we can solve this type of problem. Otherwise, the question is wrong. Hmm. In that case, we have to make the right tail test using the standard deviation of the sample. Okay, fine. Where is the standard deviation of the sample? No such information is actually provided. I don't know. They have just computed this value of t statistic, but I think some step is missing in this book. Anyway, so if the value of a square is provided in the question, so from that expression of a square, you can compute small s, n a square divided by n minus 1. N is equal to 15 over here. Anyway, I am supposing that this information is somehow due to some printing mistake in this book, somehow it is missing. Anyway, so that has to be provided. Now, by this type of value, what we got that this value of t is equal to 3.348. So we got the value of the this test statistic t, and what was the significant, what was the critical region? This was the critical region, 1.1761. And we got this value 3.348. So this value of test statistic is equal to 3.348. I am performing the test with 1% significance level. Okay, so you see over here, this value of t belongs to this critical region W. This critical region W starts from 1.1761 to infinity. So this is the what we find, that t belongs to this 1% critical region W. So if t belongs to this 1% critical region W, it means that if we get the value of the test statistic in the critical region, then H0, the null hypothesis, has to be rejected. And in that case, the alternative hypothesis has to be accepted. Okay, so this is the case when we have right-tailed test. So let's just summarize this result, that in case of normal distribution, if we need to verify this test, this null hypothesis m is equal to m0 against suppose the alternative hypothesis h1 m not equal to m0, with the fact that sigma is unknown. In that case, the test statistic t would be is equal to root over of n into x bar minus m0 divided by sigma. Not sigma, sorry, divided by small s, where small s is equal to n s square divided by n minus 1, its square root. Now, if h is not equal to m0 is the alternative hypothesis, then we shall have to perform both-sided test, like this. So, both-sided test, and there these are the this is the critical region. This is the critical region. The mean was equal to this middlemost value was 0. So if this is t epsilon, this value would be is equal to minus t epsilon, and this value, this area must be is equal to epsilon by 2. This area would be is equal to epsilon by 2. Therefore, we should write probability t greater than t epsilon, that is equal to epsilon by 2 in both-sided test. All right, and that should be computed with nu is equal to n minus 1 degrees of freedom. However, if this value, if this alternative hypothesis is written in this fashion, that m greater than m0, in that case, this type of critical region would not appear. Okay, the entire critical region will appear on the right hand side, and only in that case we shall have this type of epsilon. So in that case, this would be the corresponding relations. Okay, t greater than t epsilon, that should be is equal to epsilon with nu is equal to n minus 1 degrees of freedom. And again, if oh, I forgot to mention the critical region, that in such cases the critical region would be is equal to t epsilon to infinity. And if we have this type of inequality, that m less than m0, okay, if we have m less than m0, this type of inequality, in that case this critical region would not appear over here. Rather, it would be on the left hand side, this type of critical region, and there we shall have to write probability t less than minus t epsilon. That probability is equal to epsilon only. However, in order to identify this expression of t epsilon, we need the help of this value t epsilon on the right hand side. So although this is the critical region, so critical region W is equal to minus infinity to minus T epsilon. Okay. But in order to identify this value of T epsilon, we need the help of this T epsilon. So due to symmetry, if this area is equal to epsilon, then this much area would also be is equal to epsilon, and that's why we can again say that P probability of T less than minus T epsilon is equal to epsilon. This probability, from this result, we can easily prove that probability T greater than T epsilon, that would be is equal to epsilon, that is equal to nu, that is follows a T distribution with nu is equal to n minus 1 degrees of freedom. So from the T table, from the T distribution table, we shall have to identify this value of T epsilon. So these are the three cases for T distribution, and it is performed for the test of this type of null hypothesis m is equal to m0 when sigma is unknown. All right. So this is about the case when we want to test the null hypothesis m is equal to m0 and sigma is unknown. So that's all for this lecture. Thank you for being with us.